In this recording, we are going to discuss number 9 in the Math 313 practice quiz. It says Hillary received an inheritance of $12,000 that he divided into 3 parts and invested in 3 ways. In a money market fund paying 4% annual interest, in a municipal bonds paying 7% annual interest, and in mutual funds paying 15% annual interest. So this is supposed to be Hillary. So Hillary invested 4,000 more in mutual funds than in municipal bonds. He earned $1,340 in interest the first year. So how much did John invest in each type of fund? So to help with such a question, let's see where we can go to. Number 9, we can get assistance in question 25 on page 62 in the electronic whiteboard. So let's go there. So here we are in number 25, and slightly different. Instead of Hillary, you have Franco. So Franco received an inheritance of $12,000 that he divided into 3 parts, invested in 3 ways. In a money market fund, paying 3% annual interest, in municipal bonds, paying 4% annual interest, and in mutual funds, paying 7% annual interest. Franco invested $4,000 more in municipal funds than in municipal bonds. He earned $670 in interest the first year. How much did John invest in each type of fund? So to help solve this, which is a system of 3 linear equations with 3 unknowns, we can use Cramer's rule, and here you have a YouTube video on how this can be done. And let's go to an example. So here's an example, and the $12,000 keep on repeating. All 3 funds: money market fund 5%, annual municipal bonds 6%, and mutual funds 12% annually. The amount invested in mutual funds was 4,000 more than the amount invested in municipal bonds. The total interest earned during the first year is 1,120. So you've got some similarities and you've got some differences. So write and solve a system of equations to find how much was invested in each type of fund. So here, let's start to symbolize mutual market fund X, municipal bonds Y, mutual funds Z. So always you see X, you got to say money market fund. Always see Y, you got to say mutual bonds. And always see Z, you've got to say mutual funds. So the first, there are 3 equations that have to be formulated. Equation 1, 2, and 3. And here is how they were formulated. So for equation 1, the information that was used is the total inheritance is 12,000. So mutual funds X, municipal bonds Y, mutual funds Z, X plus Y plus Z, in total is 12,000. Equation 2, the amount invested in mutual funds Z was 4,000 more than the amount invested in municipal bonds Y. Okay, so this gives that Z now is more than Y by 4,000. Okay, so Z is equal to Y plus a 4,000. So that's why I have Y, Z is equal to Y plus 4,000. Okay, and equation 3, the total interest earned during the first year was 1,120, which of course we have to use the percentage. 0.05 times X plus 0.06 times Y plus 0.12 times Z is equal to $1,120. Okay, so the equations must be aligned in such a way that X is upon X is Y is upon Y, Z upon Z. So therefore, for the second equation, we have to send all variables on one side and equal to 0, and the letter X must appear but since it wasn't appearing in the first format, we put a 0 as its coefficient. So technically 0x means there is nothing there. Okay, subtract 1y because y was brought across to the left side, plus z is equal to 4,000. So now you have a system of 3 equations and 3 variables, and that will allow you to formulate your matrix equation because they are aligned appropriately. Now from there, we need to find 4 determinants, a general determinant, and 3 others based on x, y, and z. That will be the Cramer's rule. So to apply the Cramer's rule and to one of the ways to easily obtain determinants is by augmentation. Okay, so here we augment the original matrix, 3 by 3 matrix, by adding the two first matrices, the two first columns, sorry. So now we have 5 columns. As you can see, the 1, 0, 0, 5 was added here, and the 1, negative 1, 0, 0, 6 was added here. And then you do a series of multiplication. You start from left and you go down diagonally right. You do that 3 times, 1, 2, 3, and then you add. So 1 times negative 1 times 0.12 plus 1 times 1 times 0.05 plus 1 times 0 times 0.06. That's also the 0.06. Okay, so that's a little typo there. In a bracket, and then you minus, then you go from right to left now, starting here. Or you can start here, you can see it's on the same left to right, but in the opposite direction, the opposite diagonal, 0.05 times negative 1 times 1 plus 0.06 times 1 times 1 plus 0.12 times 0 times 1. In a bracket, you find the sum and then you subtract, and that will give you a first determinant. Then you've got to repeat this now for determinant of x. To find the determinant of x, you remove the column, the coefficients of x, and you replace it with the constants, and then you repeat the same process that was discussed above. To get the matrix for y, you replace the coefficients of x, you remove the coefficients of y, and you replace it with the constants, and then you repeat the same process. For z, you do the same, okay? And then now, as you can see, you do the same, remove the coefficients of z, replace it with the constant, but you replace both the coefficients of x and y. So you find 4 determinants, and each determinant you divide it by the original. So the determinant of x, you divide it by the original determinant, which is 1.82 in that case. For y, you divide by 1.12. For z, you divide by 1.12. And then this will give you your final answers, x, y, z. So let's see if that is what was done in this case. So here's the working. Here you can see the 3 equations. The sum is equal to 12,000. The interest was earned is 1340, and 400 plus y will give us z. Then you arrange them so that all the x's are aligned, the y's are aligned, the z are aligned. And as you can see, the only difference there is the 1340, okay, based on the interest rates. You have the 3 by 3 matrix, the 3 by 3 matrix, x, y, z, and the column matrix with the constants. You find the determinant of the original matrix by applying the augmentation method. Here we get negative 0.04. You do the same for x. You remove the coefficients of x, replace it with the constants, and that is what was done. Remove the coefficients of y, replace it with the constants, but you have to put back the coefficients of x, and then you do the same for z, and then you divide each determinant by the original determinant of negative 0.14. And here you have 2,000, 3,000, and 7,000. Okay, and it appears to be correct. So we can just verify that a negative divided by a negative is equal to a positive. So I don't even have to put a negative sign. So you have 2,000 or 20 divided by 0.14, 3,000 and 980 divided by 0.14 will give us 7,000. So this appears to be